My colleagues on this project were Steffen from Harvard University, who's with us today, and Felix Groba, who is at the German Bureau of Economic Research, or DIW Berlin, back in Berlin. So this represents collaboration between public, private, and academic institutions, which, aside from that obvious synergies, actually has some nice time zone synergies that go along with that. So back during the peak of working on this paper a while back, I sort of have a, quote, real job just down the street, so I couldn't really work on this during the day. So Steffen was nice enough to move his Harvard activities to the evening, work on it during the day, pass it along to me at night, and I would sort of go until my eyes glazed over at 2 a.m. or so, and then pass it along to Felix in Germany, who could work on it while we were sleeping. So for a week period there was about literally 24 hours a day someone was working on this paper at one point. Not an obvious synergy, but an important one. So we'll jump right in. Assessing the strength and effectiveness of renewable electricity feed-in tariffs. The background you're all intimately familiar with. We'll just run through it real quickly. Renewable electricity, which we'll call RESI, is rapidly expanding both in terms of the total installed capacity and the number of countries that are getting into these markets. And generally the literature claims that there's some justified role for government involvement here because of externalities, barriers to entry, energy security concerns. You're all familiar with those arguments. The question is, what form does that policy take, and how does policy design impact policy effectiveness? And so one way to characterize policies is along two dimensions: price versus quantity regulation, and whether the incentive targets investment or generation. The two most popular incentive types in the developed world are feed-in tariffs and renewable portfolio standards. RPS, much more popular in the US. Most US states now have them. Feed-in tariffs, much more popular in Europe. So just to give you some context, we're going to focus on the feed-in tariff part of this thing. I know there's varying levels of understanding exactly what a feed-in tariff is and how it works in the room, so we'll do a quick everything you need to know about feed-in tariffs in 60 seconds. As I said, it's price-based renewable electricity production incentive. It goes a little something like this. You have a producer of renewable electricity, sells electricity to the grid, gets some money back. The tariff simply increases the amount of money they receive back from the grid. So the producer signs a contract that allows them to sell electricity to the grid at either the market price plus a premium, or at a fixed price that completely displaces the market rate and simply replaces it with a new rate. Typically those tariffs are going to be financed by either an electricity price increase in general or by state budgets. So ultimately it's the end user that bears the cost and also derives the benefits. And at the end of the day, the idea here is to help renewables achieve grid parity. So here's a map of feed-in tariff and quota implementation in Europe. You can see there's the orange countries there are feed-in tariff countries, and the year in which they implemented the tariff is also shown. So you can see another way of showing this is graphically. See, it's kind of nicely spread out over the last couple of decades, with most of the policy implementation happening in the last 10 years, right around the same time that renewable electricity has been expanding rapidly. So the question is, what's the relationship between feed-in tariff policies and renewable electricity capacity? Well, if we do a very simple analysis and show the total number of feed-in tariff policies in blue there, and the total annual added capacity of solar, PV, and wind, which are two of the most commonly subsidized types of power, we'll see a pretty nice correlation. In fact, it's a 0.87 correlation, but as always in economics, the question is, does correlation equal causation? Or to put it another way, have feed-in tariffs significantly increased onshore wind and solar PV development in Europe? We're going to look at the last decade of data, so 1998 to 2008. The traditional approach to answering this question is a linear OLS pooled cross-section regression, where you take panel data at the country level and the year level and pile it all together into one big data set, and you simply regress it without using any of the properties of panel data to control for any characteristics of countries. So your dependent variable is capacity added or total capacity. You throw in a policy dummy that's either 0 if the policy is not in place, 1 if it is in place. Maybe you add in some controls for good measure, but at the end of the day, pretty much inevitably beta 1 is going to be positive and highly significant. So some have concluded, well, the policies must be effective then, except for two key caveats that turn out to be very important and basically throw this kind of analysis out the window. The first, which you're all familiar with, I'm sure, is omitted variables bias. In other words, what you don't see absolutely can hurt you when it comes to this kind of analysis. And number two, policy heterogeneity. In other words, not all feed-in tariffs are created equal. So the first problem, again, all economists deal with this, so we'll run through it real quickly, but and chat a little bit about how it actually pertains to this problem. But here's a relationship we're trying to get at. It's the causal relationship between policy and capacity growth. But layered on top of this, you have a number of other variables that are going to be correlated with both capacity and policy. And most of these that we can measure and control for to some degree, although it gets dicey at times. But on top of this, we have other unobserved state characteristics. These are things like culture and tradition, and things that you can't kind of put into a nice quantitative box and include in a regression model. And on top of that, we have broader trends in global culture, global technology prices, things of that nature. And so all these serve to introduce bias in the causal relationship between policy and capacity growth. So our solution to this is becoming more and more standard in econometric analysis, and that's a fixed effects model. So we're using the inherent nature of panel data, the fact that we have data for a single country across time to control for fixed country level characteristics. So our regression model is, again, pretty standard. We have natural logarithmic capacity as a dependent variable. We have SFIT, which is our new indicator to represent the strength of the feed-in tariff, which I'll get to in a minute. It's actually a solution to the second problem. We have a measure for RPS stringency developed by Yin and Powers. For all other policies, we simply include a binary variable that's on if it's in place and off if it isn't. We include a suite of socioeconomic controls and the ever-important country-level fixed effects. And we do this for energy technology I, that is solar PV or wind, in country S, in year T. So moving on to the more difficult problem, which is policy heterogeneity. In other words, not all feed-in tariffs are created equal. What do I mean by this? Well, in econometric policy analysis, the binary variable has been king for a long time, but we can intuitively claim, and it turns out statistically show, that it has not been a benevolent dictator. What I mean by this is, well, what does the binary variable neglect? It neglects the magnitude of the tariff in terms of the size and cents per kilowatt hour. It neglects the duration over which a contract is signed under the tariff. It neglects the unique production cost faced in a given market, the unique electricity price in a given market, and any risk, uncertainty, or discounting that a producer might face in considering whether to invest in renewable electricity. And so at the end of the day, I will claim here and show statistically that binary variables do not accurately represent the true production and set created by policy. So our solution to this is a little more tricky. We developed an indicator called SFIT, which represents the strength of a feed-in tariff. And it's really just uses simple algebra, but I'll take you through it real quick. FIT is the tariff amount, so in euro cents per kilowatt hour received by the producer. CT is the contract duration. Price is the market price, wholesale market price of electricity. LT is the capacity lifetime, so the number of operable years for a panel or turbine. And we have the average cost of electricity generation in euro cents per kilowatt hour. To break this down a little more intuitively, see the first term here you have the tariff amount times the number of contract years. So that's the total revenue received per kilowatt hour under the contract. But you also have to factor in the time after the contract has expired while the turbine or panel is still operating. And so we have, in those cases, you'll just receive the market price as a producer. So then we have price times lifetime of the capacity minus contract years. So that whole first term in parentheses there can be thought of as total revenue per kilowatt hour received under a feed-in tariff. We simply subtract the total cost per kilowatt hour over the lifetime of the panel or turbine to get, so we have revenue minus cost, which is starting to sound a lot like profit. On the bottom of the equation, we have simply cost again. So at the end of the day, we have expected profit over expected cost, which ultimately is return on investment. So SFIT represents the return on investment, expected return on investment rather, faced by a potential producer of renewable electricity for energy technology I in country S in year T. So let's regress this within the model specification I mentioned before and see what happens. First thing we do is pooled cross-section regression. Now this is preliminary and does not include fixed effects, so keep that in mind. We include our policy variables there, so for both energy technologies we include both the binary variable in one equation and the return on investment variable in another. We have socioeconomic controls, that's GDP per capita, net imports of electricity, energy consumption per capita, and then we have a set of fuel mix variables which represent the generation fuel mix for electricity in a given country. So I won't talk too much about the results on those second two clusters just because of time, but happy to chat about that offline. The number one thing we notice is that we get highly significant and positive coefficients on all the policy variables initially. So it appears that feed-in tariffs have driven renewable electricity development. However, as we said before, we can't interpret this as causal because of limited variables bias. So the question is, how do these results change when we include fixed effects? So let's do that. We take exactly the same model specification. Everything's identical, except we have now included country-level fixed effects. First thing that we notice is coefficients are universally lower. And so, as I said before, this implies that in the pooled cross-section regressions, we did actually have unobserved country characteristics that were positively biasing the regression results. However, even once we control for country-level fixed effects, feed-in policies still appear to have driven solar PV and wind development since 1998. And the specific interpretation of the coefficients would be, if you were to increase by 10 percentage points the ROI provided by FIT, you get 7.4% more solar and 2.6% more wind on a yearly basis. So that answers our main research questions. Do feed-in tariffs appear to work? Yes, they do. One other interesting point here, though, if you look at the coefficient on regression 1 for solar. Here there's no statistically significant relationship between feed-in tariff and solar development once you control for fixed effects. Let me say that again. According to this regression, on average, countries with a feed-in tariff for solar do not install more solar, which is kind of a striking point. However, if you include the return on investment variable instead of the binary variable, you get a highly significant coefficient and a positive coefficient. So what's the implication here? Well, we think it's that binary variables are obscuring the true relationship between policy and development. In other words, policy design matters, and it matters a lot. Something I'll get to a little bit later. So if you take one thing away from this paper, let it be this. There's 3 ways that we've identified in the literature and sort of conducted ourselves of answering this question: do feed-in tariffs work? First is a simple pooled cross-sectional approach. You use a binary variable, you do not include fixed effects, and inevitably you find that the policy is highly effective, but we think that overstates effectiveness. In the second kind of model, you're still using a binary policy variable, but now you're including fixed effects. And in these cases, the link between policy and development becomes somewhat dubious. So, as we saw for solar, it appears the policy does not drive development at all. In the case of wind, it appears to drive development, but to a lesser degree. And then the third way of doing this is this new approach of including a more nuanced indicator for the policy, including fixed effects, and ultimately reestablishing that link between policy and development. So I sort of like to think of this as a Goldilocks diagram, right? You have your too hot, you're too cold, and you're just right. And this pattern is borne out in the RPS literature as well, interestingly. So there was a pooled cross-section regression run by Menz and Backlund back in 2006, showed a clear link between policy and development. Another round of literature using fixed effects but binary controls, by Professor Carley among others, showed that the relationship between policy and development is a bit more tenuous. But then in 2009, Eden Powers developed a new indicator for our RPS strength that takes into account various policy design elements and then reestablished that link between RPS and capacity growth. So at the end of the day, if you take one thing away from the paper, let it be that nuanced indicators and smart controls are key for accuracy in this type of analysis. We sincerely hope that the days of cross-sectional regressions and binary policy variables are a thing of the past. And so in conclusion, to answer our main question, yes, feed-in tariffs do appear to have driven solar PV and onshore wind development, but controlling for policy design elements and country characteristics is going to be crucial. And if you allow me to wax philosophical for a moment, we also conclude that policy design matters more than the enactment of a policy itself. So we live in a world of political dialogue that's sort of dominated by the morality of a policy type. Should we have cap and trade or should we not have cap and trade? Should we subsidize renewables or should we not subsidize renewables? I think most of us as policy wonks understand that the devil is very much in the details, and that the dialogue should be more around how should specific policy be designed. But there's a good kind of cap and trade and a bad kind of cap and trade, or depending on where you're sitting, maybe only a bad kind of cap and trade, but you get the point. It turns out we can statistically show that policy design matters, and not only does it matter, it's the only thing that matters. So in the case of feed-in tariffs, simply having a solar feed-in tariff does not necessarily guarantee you'll install more solar PV capacity, but having a feed-in tariff that's uniquely calibrated to the market in which it affects, that's intelligently layered on existing cost curves and intelligently layered on top of existing market prices to boost the ROI provided by the policy can be statistically shown to increase solar PV development. So I think this notion that policy design matters far more than just simply having a policy is something policymakers and all of us would do well to listen to. So thank you very much. Happy to answer questions now, or I guess we're going to do questions at the end. So.